Hello, my name is Dmitry, and this is the talk about test and commit and revert. And test and commit revert is also known as TCR. This is an acronym, and this is a workflow for software development, in particular for writing code, which was popularized by Kent Beck at the end of the last year. So that's Kent Beck's Twitter. And I think the whole story was that Kent Beck was running a workshop somewhere in Norway, and during the workshop he was proposing to pretty much commit every time you have a passing test. And one of the participants suggested that from the symmetry point of view, if you always commit on passing test, why don't you always revert on a failing test? And so with a couple other guys, and this guy, they came up with TCR. And here is my interpretation of it. So you write some code in IDE, then you want to commit your change, but you cannot commit unless you run a test. This is kind of normal thing, but if you modify some code, you have to run a test. Only after that you can commit. But if you run your test and the test passes, all your changes automatically committed anyway, so you commit. And if your changes, your tests fail, then your changes automatically reverted, and you're back to the state where you didn't have any changes. So this was described in this blog post, and let's just zoom in at the diagram which compares TDD to TCR. So on the right-hand side, you can see TDD, and if this is kind of finite state machine. So here we can have green in the middle, and before writing test, you can do some cleanup, so you transition between green and green. So you modify some code to make your change easier. So you transition between all green, you do some cleanup. Then you add a failing test, and you run it to see the failure. After this, you transition into the state when, the red state, when you have broken test. After this, you make an implementation, and you transition back to the green state. And later on the right-hand side, you do some cleanup, that is like refactoring. Again, you transition from green to green. So you have two states with TDD. And on the left-hand side, this is TCR. I guess this is like some board when they didn't even come up with the name yet, didn't have the name. So you have only one state, which is always green. So you can also start with some cleanup to make your change easier. So you improve your code before making the change. And that's called make hard change easier at the top. Right, that's transition from green to green. And then you add a test and implementation in one go. So you don't run a failing test. And that's at the bottom, you add test and pass. And this is a bit tricky. So if you added a test and implementation and they pass, you transition to the new green state. But if you added test and implementation and they don't work, you still transition to a green state, but it will be your previous state. In any case, you always stay in the green. Right? And the last step of refactoring stays the same. So that's like comparison in terms of like finite state machine. Obvious important question, why? Right? And there are a few reasons. One of them is that this workflow kind of pushes you towards making really small changes. There are other workflows and other tools which also help you make small changes, but I think it's like this workflow forces you more than others. Because if you make some changes and they disappear, that's wasted work, and you don't want this to happen. Even on psychological level, it's loss aversion, bias, and so on. So it forces you to make small changes, and small changes that also can improve the way you approach problems and so on. So it can improve the quality of the software you're writing. And on a larger scale, if you imagine many developers doing this, you can look at this as an ultimate continuous delivery when lots of people making small but meaningful and changes which can be integrated easily with each other because they're just really small. And the third reason is that we don't really know, because this is a new thing, we're kind of exploring the idea. There might be a better way to say it. That's like not that we don't know, but because we can. Right, so that's, I guess, just to capture the spirit of this thing, it's like up to us to figure out what is good about it or what is bad, so it's up to you. I think there is also an interesting analogy with computer games and with arcade computer games when you play as a character, and once you die, you pretty much taken to the safe place, where everything was good. So TCI in this respect is similar, so if you broke your code, you'll be automatically taken to the previous place. I guess the analogy breaks a little bit because you don't have lives with TCR, so like in Mario you have lives and then you're dead. But maybe it should also be integrated, and like after you reverted 10 times, you need to take a break. So because this was just slides, and to make it more concrete, I'll show how you would write a code to solve Fizzbuzz woof problem. For those people who don't know about Fizzbuzz woof, it is a problem for interviews or for code cutters in which you need to write a function. This function takes an integer as an input and returns a string. So if the number passed to the function is divisible by 3, you return fizz. If it's divisible by 5, buzz, by 7, woof, and if none of the above, then you just return the original number converted to string, and also the combinations of those numbers. To do this, I will use IntelliJ with this plugin, which I wrote called limited WIP, limited work in progress. It has like 3 components. One of them is for TCR. So so I'll use IntelliJ and Kotlin because I write in Kotlin these days. So here is the basic hello world. So what we have here is a test class and a test function. Right? And to start with, we want to write like a failing test. So we write Fizzbuzz function takes 1, and it should return string 1. If we want to commit at this point, then it just doesn't work. And the plugin tells you cannot commit because you didn't run any tests. So now I'll create a function, and as the simple implementation, just generate the function. And there is this to-do function. In Kotlin, what it does, it just throws an exception. So basically, the test will fail. So if I run this now, as you would expect, all the changes are gone. So now, basically, I have to type it again, then do implementation. But this time, we'll do like the simplest possible implementation, just return 1, right? And as you would expect, this works. The next step would be go to add 2, and to make this work, we do end to string instead of hard-coded 1. Then we commit, tests pass, all the changes we run tests, they pass, and all the changes are committed. Then we move on to fizz, and for fizz, we can hard-code n equals 3, which is kind of, again, the TDD way to do minimal step. This works again, then we can do for and buzz. For this to be passed, we need one more condition for n equals to 5. So we can run this is passing. And then we can add one more fizz, but then we cannot use equality, so we need to change it to reminder. So on line 16, we can now change reminder equals to 0, means divisible by fizz. If we run this also passes. And we can add 3 more conditions just in the test. And if we run this works. So those 3 conditions, they didn't need any change in actual code. Now we can do buzz. Again, we do on line 21, we do remainder, and this works again. There is one more thing, which is combination of both 3 multiplied by 5. So like Fizzbuzz of 3 multiplied by 5 should be Fizzbuzz. And we need one more condition here. And this works as well. So this is kind of the basic Fizzbuzz without woof. And at this point, I think this function is not very idiomatic Kotlin, so I would kind of change it a bit. So I'll do some refactoring. So as the first step, because all ifs they return, we can add else in front of them. And if we run this, tests pass, and we commit straight away. Similarly, we can lift return out of if statement, because in Kotlin, if else is an expression. Just run test commit. Then we can replace if with when construct, which is kind of switch in Java, but it's also an expression. And we can convert the whole function to an expression body. So it all passes. So the next step to do woof, and if we just modify this line 12 and try and run, as you would expect, just everything, it takes us back. Right, so we have to have implementation for woof. Now we hard code again just 7, then we do combination with fizz woof, then we have this passes, then we have buzz woof, and we run this, and the change fails. So at this point, we have this, so like change failed, like why, right? And we have few options at this point. The old school option would be eyeball the code till you see the problem, or debug the code once you think something is fishy. But here we don't have the code anymore. So this is not an option. With the test, we can actually look at the failure, and that's what I'm going to do in this case. And there is a third option, is to kind of redo the change in a slightly different way. So looking at the failure here, I don't know if anyone noticed, but there was like a cheating way. There was a typo, so it was bizwoof instead of buzzwoof. Like this copy-paste error, when you copy-pasted code, modified, but not the whole string. So because it was an obvious problem, like I'll just retype it again and do buzzwoof in both places. and this passes. And there is this third thing, which is combination of Fizzbuzz woof, another huge condition, do some formatting. So that's how the whole thing looks like now, Fizzbuzz woof, right? So, and this is what it looks like. You can see if it kind of grows exponentially already. What if we had, for example, Quirks, which will be 11, and these numbers, they look suspiciously prime. So what if it was like a problem to do the same thing for all prime numbers, right? So it needs some refactoring. So also the thing I forgot to mention is that the order of these conditions are important. So if we swap lines 26 and 27 and run the test, we're taken back to the previous state. So again, TCR kind of, like in a computer game, keeps us from failing. So to make this better, let's try some refactoring. Let's write fizz function over there, and then use fizz inside Fizzbuzz. And if the result is empty, we'll run the old code, right? And if we run this, it just fails. And it's like really sad, because again, we're in this situation when we cannot debug what we just had. And this time I'll try a different approach by just trying to do the same thing, but in a smaller steps and in a different direction. So let's try at the bottom of on line 34, add condition if empty, and to string, and replace on line 33 and to string with empty string. So this should be equivalent, and this works, it's good and committed. Then we can define fizz function and not even use it and just run this. This will obviously work because it's not used. And then we can kind of use fizz in Fizzbuzz. Also, we need to, because we're already doing fizz, we need to delete all the fizz things from the condition. I guess that was the problem last time. And we also need to wrap fizz plus when into parents so that if empty is applied to both. And as you can guess, at this point, it's kind of quite a few changes, like really stressful. And whenever I tried Fizzbuzz TCR by myself, I had this feeling, it's like, I'm afraid to run this thing. But luckily, this time it works. Right? And then now it should be obvious how we can add buzz. So we define buzz in a similar way, added to there, deleted from the condition. Again, run the test, they pass, we commit, and then woof is obviously just can be replaced with when, and that's like the final version. There are some weird things, like some quirks with TCR. One of them is that, as you could have probably guessed, that you lose stack traces. As soon as you get like some failure in actual code, you can click on the stack trace, but it won't take you to the source code because it's gone. Right. There is also the issue of reverting failing tests. And some people, they complained that like you obviously cannot do TDD anymore with this. And there are some suggestions, for example, to not revert tests and so on, but I guess it's just open question. There is another obvious thing which I skipped is what about commit messages? In the plugin I showed, there are options what to do. You can take the name of the current change list in IntelliJ or reuse commit from the previous message. Or you probably could hard code, or maybe you want to use the message of your task and then squash all your commits into one big commit. So it's like an open-ended question. And there is another big question, do you want to commit or commit and push? And all of these things could be like just another lightning talk. So here is a recap. So basically TCR that you make some changes, but you cannot commit them until you run tests. If tests pass, changes are committed automatically, otherwise tests fail. So this is a bit like arcade game. So in a way you can think it's kind of gamification of your workflow in a way. So and the most important point, just try it yourself. And as the name implies, it's pretty much the command line which you can use. So instead of test, you can do maven test and use git commit and reset. This is not an actual command, but that's the gist. Or you can also use the plugin if you use IntelliJ. So this was test and commit and revert. Thank you for watching. Should I switch to questions now? Why tests? Yeah, I hope I answered because that was the idea. Can you run test without commit? No, not with this thing. So if you run test, it's automatically committed.